Welcome to my projectbazaar.com.
Now we discuss about the product for star type architecture with low transmission latency for a 2D mesh NOC. Now we discuss about the abstract for the product. A 2D mesh on chip topology is characterized by relatively large average distance between nodes. When the network size increases, long distance traffic suffers from high transmission latency. Moreover, the blocking probability in the formful routed networks increases. In this paper, we present a improved design of 2D mesh NOC topology which can reduce the hop count of long distance traffic. The basic concept of the design is separation of long distance traffic from short distance traffic. We divide the mesh into several 4x4 mesh and connected the central nodes of each 4x4 mesh. Moreover, the central nodes of each 4x4 mesh are connected to the diagonal nodes. An example for the red node of a reddish wire provides the path from the long distance traffic. The central nodes to each mesh are linked to respective diagonal nodes for the traffic of second level mesh can be reduced in the original hop count for the architecture. The 2D mesh on chip NOC is a popular NOC topology because the network scalability and use of the simple routing algorithm. However, the long distance traffic may suffer from the high transmission latency. In this paper, we propose a improved design called star type architecture in which the long distance traffic is allowed to traverse the additional second level mesh topology. Simulation results diagrams the star type NOC architecture designs for overall NOC design. Network on chip architecture represent the promising designs of paradigms to hope to increase the communication requirement in digital systems. NOC has emerged the virtual factor that determines the performance and power consumption of many core systems. A novel switching mechanism called virtual circuit switching is implemented with circuit switching and packet switching. Next, we see the flow diagram for the product. First, the input data bits are applied to our NOC architecture. The network on chip, we design the 4x4 based NOC architecture design. These 4x4 designs mainly consider for the 2x2 designs based samples or overall final architecture designs. The final architecture designs master and slave router designs to be combined for 4x4 NOC design. Master router mainly used to select the input and master internal section and the output for master external section. The input and the another router positions to be slave router designs. First, we design the every master internal and external routers and the slave router for overall 4x4 NOC architecture design. Then combined were 16 router to be designed for overall architecture and to star based processing to be applied for central master router for 4 router for 4x4 routing designs. Then to calculate the network interface. The network interface is mainly used to pass the router for master internal and slave positions results to apply for our NOC IC designs. This NOC to be network for passing the data input for router to router configurations and the network interface to initialize the routing positions and to passing the central switching conditions and to selection for 4 routing positions. Then the passing for network interface parallel to internal and external position for each and every master and slave router designs. Then the switch and selection control mainly is to transfer the network interface router data and to select any one of the selection control and based on the internal positions and to external conditions. Then the selection output data to be passed in each and every routing selection positions. This selection position again to pass the network interface conditions. This network interface condition turn to apply the 4 routing positions for master and slave position, then to pass the master external router. The master external router to be selected for the 4 slave positions result and to check whether the what result to be passing to the outer result. So these results to be selected for based on the selection control and to pass the on-chip peripheral bus. This on-chip peripheral bus to be controlled for overall pipeline connection for forecast for router architecture design. Then to select the overall function and to run the our forecast for NOC architecture design based on the star topology based process. And finally we see the output for the product. First, run the Xilinx ISC project for router architecture designs. Our program was developed in VHDL language and using the structural modeling process for router configuration in forecast for NOC designs. Next, to select the main router function and to select the simulate model, then to run the simulate behavioral model for overall forecast for NOC architecture design. Then to create the Xilinx ISM project, this ISM project is mainly used to simulate our overall NOC design. Just we apply the binary input data for forecast for NOC input and to get the output for star based NOC architecture designs based on our selection line. This is the simulation process. Then to apply the clocking signal for overall architecture process. Then to run the reset function for our architecture. Then any of the address to be passed in our NOC architecture designs. Writing signal to be activation for. Then the enabling function to be selection based logic. So activate the one functions for writing the router architecture and read the data for every router architecture functions in focus for architecture. Then to apply the selection based logic. Then any of the binary data input to be applied for overall architecture. Then to activate the reset functions and to apply the clocking section. Then to deactivate the reset function and to generally apply for clocking function in every architecture design. Then to transfer the data for each 2x2 router architecture design and to get the output for another result whichever the selection based lines and to passing the results and to apply the final output results for our clocking based output logic due to the our NOC architecture designs. This is the final simulation process for overall architecture designs. This is our continuously apply the input and 16 clock signal to be get the final output results for overall architecture result. This is our processing the overall architecture results for simulation results for NOC architecture designs. Then apply the 16 clock by clock input for our NOC architecture designs. Then to close the simulation process and to select the implementation work. This implementation work to select the main functions and to run get the view RTL schematic. The RTL schematic add and create the schematic. This RTL diagram to represent the what are the logical blocks present in overall architecture. These are the 2x2 router architecture. This is the network interface and to processing the switching activity and final get the master output results. This NOC designs same for the overall architecture function for each and every 2x2 router architecture designs. This is the RTL diagram for overall architecture process. Then go to the technological process. This technology diagram mainly used to what are the large lookup tables and input output buffers. Then wire connections, flip-flop pairs to be placed in our overall architecture. This architecture mainly represents the area of NOC forecast for NOC architecture designs for final output results. Then go to the design summary process. Then design summary process to synthesis the final synthesis report for our architecture designs for device utilization process and to calculate the timing summary results. The device utilization process mainly represents the lookup table and flip-flop pairs, then the bounded input output functions, and the Xilinx design timing summary results to be represent the minimum period time and clocking frequency level, then the before and after clock function for overall architecture design. These are the final output results for our focus for NOC architecture designs.